All right, here we go. We are back with a rectangle problem. And so hopefully you know the 7 properties of a rectangle. And I'm flat out telling you this is a rectangle. Doesn't have any tick marks, but as you can see up here, this is a rectangle, so it does have all 7 properties of a rectangle. All right, so what's the goal here? The goal here is to find x, y, and then the perimeter of the entire rectangle, and that's what we're going to find at the very end. Meanwhile, we have to know what x and y are. So what do we see? Well, there's a lot of geometry going on in here. Let's focus on some of the things that I see. Well, I see a side over here. On this side, we have an expression for that's 7x minus 1. That's nice. And then we have a different, this is not a side, this is a part of the diagonal. That's nice. And notice I used a different color in there. You may be asking yourself, hey, are those 2 segments equal to one another? Well, if we know our properties of a rectangle, those 2 are not. It turns out the opposite sides turn out to be congruent. This yellow side and that yellow side, those are congruent. Those 2 beige sides, those are equal as well, congruent as well. But the blue one and the beige one are not. It does turn out in a rectangle that the entire length of the diagonal is equal to the other length of the other diagonal. That's one of the properties of a rectangle. And we also know, since every rectangle is also a parallelogram, that the diagonals bisect each other. So if the diagonals bisect each other and they're congruent, then it turns out all 4 of these segments in here are congruent. So this is really good news, because now we can see that 3x plus 12 is now going to be equal to 4x minus 1. So when we set up our equation to solve for x, notice we're not using 7x minus 1. It's only going to be 3x plus 12 is equal to 4x minus 1. And hopefully when you solve for this, you get x equals lucky number 13. All right, so we have found 13. That's nice. Well, if we found 13, that's x. How does that help us find y? Well, there's a lot going on in here. There's many triangles to see. So I'm going to try to focus on the right triangles within a rectangle. And so there are a few right triangles in a rectangle, and I'm going to try to use some color in here to kind of showcase those triangles. And so I'm going to do that right now. Turns out this is a right triangle. Where are some other ones? Well, turns out this one is also a right triangle. And there's 2 more actually. Where's another one? Well, this blue one way up here. And then the last one is this beige one all the way over here. All 4 of those overlapping triangles turn out to be congruent. Excuse me. Yeah, they are congruent, and they're also right triangles. So what does that mean? Why are we talking about right triangles? Well, one of the clues to finding y in here is we have to ask ourselves what shapes produce right triangles, and we just showed you that rectangles do. Well, what other shapes do? Well, think about it. Rhombi do. So we got rectangles, we got some rhombi, and then what's another one that produces right triangles? We got some squares. So where are the right triangles? Well, I just tried to showcase a moment ago where those right triangles are. Hopefully you saw those 4 overlapping right triangles, and it turns out all those triangles happen to be congruent. And then the most important question, what theorem can we always use to find the lengths of the side in a right triangle? And hopefully you're thinking Pythagoras. All right, so let's move back across to our picture in here. And when we see our picture, I'm going to showcase this triangle in beige right here. That's one of the right triangles. And I'll put this right angle sign right in here to see that it's a right triangle. Now, I am going to erase this 4x minus 1 if I can do that. Nope, I can't do that. And let's go back to fill in some of these lengths in here. Well, if I substitute in for here, 3 times 13 is 39 plus 12 more. I believe that is 51. Well, if that's 51, we discussed a little bit a while ago, that's 51 as well. So with this line and that line, but we don't need that in the context of our beige triangle in here. So in the beige triangle, hopefully you can ask yourself, what is the length of that particular side of a right triangle? That's right, that's the hypotenuse. And so now with a little more substitution, we can figure in this other length of that leg of the right triangle. Well, 7 times 13 is 91, and 91 minus 1 turns out to be 90. So if I were to draw a little triangle down in here to kind of simulate the lengths of the sides that we have so far, we have 102. Well, how did I get 102? What I added up 51 and 51, that gives me my 102. And then this 90 is that 90 right there, and I put a y down at the bottom here because that's the length of that side, and that's y. So hopefully you can see now I know 2 out of the 3 sides of this right triangle, so I am going to use Pythagoras, and hopefully you can set up Pythagoras and solve for Pythagoras. I'm going to go y squared plus 90 squared equals 102 squared. So hopefully you know how to solve for Pythagoras. I am going to make this a little faster. Hopefully you can do this on your own. 102 squared minus 90 squared, and I take the square root of that number. It turns out y is exactly 48. So I did not show my work, so make sure you know how to manipulate that equation. Put some numbers on the other side and solve for y, and you get y. It's actually plus or minus 48 technically, but in the context of a geometry problem, we cannot have a negative length for a side of that right triangle, so we only stick to the positive 48. So let me fill in 48 here, and then we are almost done with this problem. Y is because we just found x, we just found y, and now we got to find the perimeter. So earlier we discussed one of the properties of a rectangle, which is both pairs of opposite sides are congruent. So if that one's 48, the one up above is going to be 48. And if this one's 90, it turns out that this one is going to be 90. So if I take my calculator, which is right next to me, which you cannot see, I got 90 times 2 is 180, plus 48 times 2, all together, excuse me, 90 plus 90 plus 48 plus 48. I got 276. 276 is the perimeter of this rectangle. So hopefully you learned a lot about the properties of a rectangle, how to analyze it, how to see the right triangles, and what theorems to kind of use on your friends with right triangles in here. And hopefully we'll check out the next video, right?